All right, so the scenario is that it isn't unusual to have several variables that you want to use together. So for instance, if you're writing some application to, I don't know, keep track of grades or scheduling or something like that, then maybe you need to keep track of statistics of a student, such as their name, their age, their grade point average, and you could certainly create 3 variables to keep track of those things, but it's kind of a hassle to try and then take these 3 variables and pass them around your application. You got functions and other things. So that's what the motivation is behind having this idea of a structure, where the keyword is struct. Give it a name. And then I can say that this person, as I said, has a name, has an age, has a grade point average. This, like so many things, is just information for the compiler. I have not created a single thing by doing that. I've merely said, hey compiler, I want to create this structure called person, and should I decide to create one, these are the elements that it has. Okay? To actually bring one of these into existence, then, in fact, I would go so far to say is that the presence or absence of this doesn't change the size of the program that you create. I guess I should prove that. Okay, so this is a.out. This was the version where I had that structure declaration. This tells you how many bytes the program that you run is, and then this is how many bytes the program is when I took it out. You haven't done anything. That's what I'm telling you. It's information for the compiler, should you decide to use one. So let's decide to use one. I go ahead and I say person. I can give it a name. Let's say student. And note that you use it just like you use anything else. To create one of these, to create a string, you say the kind of thing, string, and you give it a name. This is the kind of thing that I want, and I give it a name. So that's a variable I can use now. For me to use it, you refer to any of these 3 components that comprise it. So I can initialize the student's name by saying student.name. And so that's that syntax. This syntax right here should start to look a little bit familiar because we've been doing some of that with strings, right? We've said string, well, I've got a string here. Let me ignore that. String color equals blue. And then I can say color, maybe I print it out to the screen, color at 2. That'd be the 3rd character because counting starts at 0. And the 3rd character is U. So this syntax of the name of the variable and then a period, so that you note that similarity there. In fact, C++ adopted this syntax from the C language. These structures go all the way back to the C language. The difference between this and this is that this is data, so I don't have anything after that. This right here is actually a function. And in order to call the function, you need, just like in mathematics, you need the parentheses, and you throw something in the parentheses. We will actually, not too far down the road, we'll start actually creating types that have functions that you can call like this. So we'll be creating our own versions of these kinds of things here, not too far down the road. All right, anyway, so to then just keep with the pattern. That's all there is to it. You can print them out. average GPA. Okay, so hopefully that's fairly straightforward on how you use them. What if you want to create a function that uses them? That's fine, just create a function. Let's call this function, maybe I just want to move this printing routine into a function rather than having it in main. So I could create a function. It's not going to return anything, so I'll say void. I'll call this, how about display student? And then help me out. Then what would I pass into this function? What kind of thing is it?
String, right?
No, I want to print. I want to print out. I want to print out the student. So what kind of thing is the student? That's the kind of thing it is, and then I have to give it a name. Doesn't matter what I give it. I'll give it FDSA. And then what I can do, then I'll just move this stuff. So what do I have? This is lines 24 through 27. Let me move that to say after line 11. Now I have to change this up a little bit. This is now FDSA. And maybe I'll just make this kind of English prose. I haven't called the function yet. Let me do that again. All right, how can I call the function? What's the name of the function? Display student. What's the argument that I'm passing into the function when I call it? Person's the kind of thing. I don't want the kind of thing. I want to pass the actual variable in.
Student?
Yep. So I pass in student. Recall that the language is what we refer to as a pass-by-value language, which means that FDSA becomes a copy of whatever is in student. So we can actually change things in FDSA in that function, but it is not going to affect student down in main. Yeah? I think that's it. I guess I'll leave my little color exercise there. And there we go. I'm going to move lines 4 through 8. I'm going to move them down to below line 16. I'm going to get an error. And I'm going to get that error on line 5. Does anyone know why I'm going to get an error on line 5 when I tried to compile it? Say that again? Right, the compiler's going to hit line 5 and it's going to see person FDSA and it isn't going to have the slightest idea what a person is. Okay, the compiler's not very smart, just starts at the top, churn, 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 interpreting the stuff that you've entered and turning that into a program you can run. So it isn't clever. It doesn't it would be called a multiple pass compiler if it actually went through it more than once, but it doesn't do that. So yeah, that's absolutely correct. So we have a general principle here that before you can use it, you have to tell the compiler what it is. And I know I said this before, but it bears repeating. The reason you're including IO stream is that you can't do anything with CIN or COUT unless the compiler knows what those are all about. And that's exactly what that include statement is doing, is there is literally a file. You could go out there and find it. There's a file out there called IO stream. And curious about how big IOStream is? As an aside, what I've done is I've just moved this back to before this, so it'll work now. But let me take this sidetrack for just a moment. I can do, this is a simple little utility. WC means word count. I give it the -L option. That means that I'm interested in the number of lines that are in that file. So that file that we've been playing with is 29 lines long. I can do that option to G++ tells me to do all the include statements. If I wanted to be real technical about it, I would say that -E says run the compiler's preprocessor and then stop. So what that means for practical terms is it'll do that include statement where we include IOStream, and then it'll stop. It won't finish compiling. What I can do is I can take that output that it's going to give us, and I can pass it in the same command, and I can find out how many lines of code that the compiler actually sees. So we see 29 lines. What the compiler sees is 43,000 lines, because IOStream contains about 43,000 lines of information explaining how it is you can use CIN, Cout, and about 300 other things that we haven't even talked about that have to do with input and output. Okay? So referring to that as an include statement is a very appropriate name. It literally, there's nothing clever going on. It literally is putting a copy of that file right there at line 1. I showed the line count. I can get rid of that, then it'll spit what the compiler actually sees to the screen. Okay, so that's what the compiler sees. So the pound include, all those things that begin with the pound actually occur before the compiling begins to do these things, such as getting copies of files and shoving them in right at that location. And we can see here's all the code that we were just working on, and all I have to do is scroll up enough, and then you can see this is the very end of those 43,000 lines that comprise IOStream. Okay? So again, the purpose of it then is to let the compiler know about stuff that we might use. We're not under any obligation to use it. As I said, this has information on doing 300 different things having to do with input and output. Obviously, when we walked in here at the beginning of the semester, we started doing input and output immediately, but we didn't do 300 different things. So we're not under any obligation to do the things that we tell the compiler about. We're just making the compiler aware of it so that if we do use these things, it'll be happy. So using that as kind of preamble then, our programs are starting to get sophisticated enough where we're going to want to start to divide these into separate files. And I can rationalize that with this short program here. I've got a main program. I've got a function here, and maybe I, for whatever reason, I want to put this function in its own source file. Now, I have to concede that, this is a toy example, and if I was to show this program to a seasoned software engineer, they aren't going to request the fainting couch because I have this function in the same file as main. It's not a big deal. But things do get complex. What we have here is one function that very quickly turns into about 300 functions, and you're going to want to divide it up into 20 to 50 different files, depending on how you want to organize this thing, just simply because it's easier to work with. Pick a file that has, say, 30 to 300 lines rather than one big file that has thousands and thousands of lines. So, fortunately, the compiler will support that. I can take lines 10 through 15, and I can write that out to, I'll call this my display function.cpp. Now that I've done that, I can take lines 10 through 15 and I can delete them. So this is all I have left here. Now, in order for me to run this program now, it is not enough for me to do what I had been doing. Whoops. Well, let me tackle this problem first. All right. Actually, I'm not sure what that problem is. Let me see, what do I have going here? Oh, so here, okay, so here's the first problem. I'm trying to compile the program as I always have. We have the same issue that we've been talking about. We cannot do it until we tell the compiler what it is. I have moved this function out of this file, so now it hits line 17 and it doesn't have the slightest idea what that is, and it generated that error that we were seeing. So I have to go ahead and tell it what it is. And the way you tell it what it is you give it what's referred to as a function prototype or a function declaration. The terms are used interchangeably. It's a description of the function that helps the compiler know how to use it properly. So I just say I've got a function, it's called display student. It's going to take a person as an input parameter. And then here's an interesting thing. What you put here, for this bit here, the compiler doesn't care. I can actually leave this off altogether. For the compiler to know how to use it, it doesn't care what the name of the argument is. It just cares about the kind of thing it is. It's a person that's going to be going into this function. That's all it needs to know. So every once in a while you'll see this. It is a little bit disconcerting to not have something there. So typically the programmer will put a word here that kind of gives you a hint as to what the purpose of the variable is. Okay, so the person variable is supposed to deal with students, so that's put there. But just to emphasize, and maybe I am going to emphasize it in this case, I'm just going to do that, give it some garbage name, just to really drive home that it doesn't matter at all. All that matters is that I have a function, it's called display student. It does not return anything, and it has one argument named of type person. That's all that matters in order for line 19 to work. So that way, if I instead say display student, then that's an example of me not using the display student function properly. And we'd get a complaint. Or if I said integer x equals whatever display function returns, that won't compile because up there on line 4 we said this function doesn't return anything. So you see how this helps the compiler know how to use this thing properly? It can then help you out if you inadvertently use it incorrectly. All right. So let me try again. This will get us most of the way there, but not quite all the way. So, do I have my typo in there still? Yeah. So now we've got all the same kinds of problems. On line 4, I've said that the kind of thing that this function takes as an argument is a person, but again, the compiler doesn't have the slightest idea what a person is. So I need to make sure that that structure declaration that describes what a person is comes before I describe what that function does, or what I describe what the function signature is, I should say. So now when I move it below, the compiler will see person. Now it'll see line 11 and be happy with it, be happy with this bit right here. And then finally it'll hit this line and it'll be happy because we've already described what that function is. So now, let me try again. There. That actually, you have to take it on my word that it actually compiled just fine. The compiler was peachy keen. This is an error, obviously, but this actually isn't an error caused by the compiler. This is a totally different program that is complaining. And in fact, the name of this program is called the linker. There's the name of the program that I've highlighted. Just like ls or cd, those are all commands. ld is a command as well. The job of LD, and it does run whenever you all have compiled a program, LD has been running at the end. Its job is to take compiled definitions of functions and link them to places where you are calling the function. Let me make that obvious or clear. This compiles fine. However, there's one last stage is in the end, we don't know what this function does. We have that in a totally different file. So what we need to do is compile the file we're looking at. We need to compile the definition of that function, which I'd put in a totally different file, and the linker will join them together, the call in the file we're looking at with the compiled source in the other file. That's why they call it the linker. It literally links calls to where those functions are. So the way you compile, if you need to create an executable, it's no longer enough for me to just specify one file. I need to specify all the files that are involved in that application. And I've forgotten what I called that, my display function. Let me actually let me try to create the same problem here. I want to get, if I do this by itself, it will compile, when we're done, it's got an error in there. When I've got my display function all working fine, it'll compile just fine, but it will get a linker error as well. And why do you think my display function, as written, would end up a linker error? Because if I tried compiling this, that's not a running program right there. Every running program that you have has to have a main function. So if I compiled this by itself, it would say, hey, there's no main function. Yes?
It also doesn't know what person is.
Right. And so that's where I did my little tap dance talking there, saying after I fix it, right? And you're absolutely correct. This is going to screw up because it doesn't know what a person is. Well, we had that in this one, so why don't I just grab a copy of that? So let me take lines 5 through 9, and I want to copy that into, what word? No, let me do it this way. I was trying to remember the syntax to that. All right, so just to show it, it'll be in the recording. I said lines 5 through 9, I want to yank. Remember that yank is Vim's term for copy. And then I can give it a letter of the alphabet. I'll give it letter A. Any letter of the alphabet's fine. Then later, I can go into a different file. I can even quit out of Vim and go into a different file. And I can grab that. What I typed was double quote A. So remember, P is the paste command. So that said, the double quote is a bit of syntactic sugar, but the double quote is saying out of letter A, I want to put whatever I'd grabbed in there. So that was that little trick. So there we go. There's enough. Now I've described what a person is for this file. So this file, when it compiles, the compiler will be happy about what we have here. So let me go ahead and try that. So now, why is the compiler complaining on this file? It does not know what cout or ENDL is. So we need to tell it what cout or ENDL is. There we go. No. So we've been using namespace standard. We could do that here. As you get into more and more advanced classes, they start frowning upon using namespace standard, so I'll just put the STDs right there with cout. You could have done, I don't care, you could do that as far as I'm concerned with me using namespace standard. One more try. All right, let me try compiling that other one. So note, for both of these, we have the exact same problem, which is both of them are now compiling just fine, but on the one hand, the linker can't find display student. On the other hand, the linker can't find main. So we need the linker to link them both together. And if I tell G++ both of these CPP files, then the linker will have both of those at its disposal to link together, and we have an executable. Okay? And you can see that it's successfully compiled. I can run it. This is the exact same functionality we had 15 minutes ago. All I've done is I've gone through the trouble of splitting these up and the huge headache of having to say over and over again what the compiler needs to know before I can use it. So let me bring these up in these two panes here. This would be that one. This one would be, all right. So here are the two files, and this works just fine, but it is error prone. And the reason it's error prone is I can extend this exercise. I could create a third function that needs to do something with the person. And now in that third file, I would have to have this declaration right here. And then in the fourth file, I would need this. In the fifth file, right? And what it becomes both a error prone, because you would have to basically transcribe or copy and paste this declaration over and over and over again, and you might make a typo at some point. And some of these typos can be insidious. For instance, I can do that, and the one on the right side will compile fine, the one on the left side will compile fine, the whole thing will link together, and man, it is going to look like fireworks when you run it. Let's try it. It's been years since I've tried anything like that, so I'm okay, you see how it's garbage? Because the one file thinks the order's name, age, GPA, and the other file thinks it's GPA, name, age. I don't quite remember the order. So it's main, let me actually bring these just both up. So here, main passes in, basically this data is passed in this order, name, age, GPA, and on this side it thinks it received it in order age, name, GPA. That's why it looked like garbage when we actually displayed it. So if we're careful, we can make this work, but it's a lot of extra typing, copying, and pasting that we don't want to deal with. Do we have anything out there that allows us an easier way? And yes, absolutely. Every time we write, could you imagine if in the first week of this course I said, okay, we're going to want to use some input and output. The first thing we have to do is transcribe these 43,000 lines. And then you can do hello world, right? No, what's been done is all of that stuff's been put into a file that we include. And we use that exact same technique here. We will take this information here, and in fact, let's take this information here and just put it all in a header file. So I'll take lines 5 through 11, and I'm going to write that into header fun.h. Doesn't matter what you call it, but hopefully you don't use lane names like I do. And now I can get rid of all of this here, and I can simply include header fun.h. And I can do the exact same thing here. I can get rid of this, and I can pound include header fun.h. Just to quickly look at it, that's what that looks like. And now, when I quit out, let's find my original, and there we go. So that's the reason we have header files, is it makes our life easier when we need to use something over and over and over again. We can just describe it to the compiler in one of these header files and then include it wherever we want to use it. And again, we don't pay any penalty. As I said, just because it's in the header file doesn't mean we have to use it. It means it gives us the ability to use it should we decide to. Like the 300 things in IOStream. There is a little bit of a postscript to that, and that is that the compiler doesn't like being told things more than once. And although you know and I know that none of us would be silly enough to do lines 3 through 7, we're not idiots, it is possible for this to happen by accident in complex applications, because we can have pound include statements inside of header files. So I pound include this header file, which pound includes this header file, which pound includes this header file, right? You just have one pound include, and there are 4, 5, 8, 10 different files that are actually being copied into your program. That's actually what's happening with IOStream. It isn't one monolithic file. It's probably including half a dozen other files itself. When you do that, it gets complex enough that you can easily, by accident, have some sort of loop where then that first file you were including way up here is getting included again, in which case you're seeing it twice, and the compiler will give you the complaint that we saw when we did it like this. So we need a mechanism for preventing that. And the traditional way of doing that, what did I call that, header fun, is, and you can just take this as a recipe. I'm going to refine this in just a moment. These are what are referred to as header guards. They guard against accidentally including this file more than once. And you'll note that they begin with pound signs. So these are actually just like the pound include is for this preprocessor before we hit the compiler. This stuff's for the preprocessor before we hit the compiler as well. And what this is in essence saying, this N means not. If this thing, whatever it is, has not been defined, go ahead and define it, and then all this stuff gets included. And then here's the end there. So if the second time you try to include it, it says, if this is not defined, but it is defined, right? We did it the first time we included. So if it is defined, it's going to skip all that and just jump down here. So that's just the mechanism to guard against accidentally including this more than once. If that's a little bit hazy, don't worry about it. Take it as a recipe. The only thing you have to watch out for is a lot of times folks will forget to get that N for not, and that's going to give you all sorts of problems. That means if this is defined, then go ahead and do all this, and that's exactly the opposite of what you want. So you want to say if it's not defined, do all that. The final thing is I typed in something random here. What should you type there? It doesn't matter. It needs to be unique. And that's where the problem is if you got 50 or 60 header files, what can you do to guarantee that I'm going to call it a symbol, that the symbol that you put here is unique? And so rather than coming up with some list that you write on a piece of paper and you scan it to make sure that you've got a unique name that you throw in here, one thing that's unique is the actual name of the file that it's in. So by convention, there's nothing syntax-wise, but by convention, in order to ensure that this is unique, you use the name of the header file. And by convention, again, you don't have to, you put it all in uppercase letters. And then the final thing is that this stuff for the preprocessor doesn't like periods, so periods generally get converted to underscores. Yes?
Is it case sensitive?
It is case sensitive. So again, being in all uppercase is by convention, not by requirement. Yeah. And so that is that. Now that I've got that header file and these header guards, let me come back here and abuse this again. We can see that it compiles just fine because those header guards did in fact guard me against accidentally including it more than one time.